welcome back for the online session. In this class, we are going to discuss about the in-order traversal. In the previous class, we have discussed about the pre-order traversal. So let us see what is in-order traversal. So as for the in-order traversal, so first again you have to start with again root node. So you should begin with what root node traversal begin should be start from root node. So first what we do in the in-order traversal, visit the left subtree is a recursive function because it is a binary tree. So visiting a left subtree is again a recursion. Then after visiting a left subtree, you have to visit the node. Visit the node means what? Display the data of that particular node. Then next, third step is what? Visit the right subtree. After visiting a node, you have to visit the right subtree. Right subtree is again a binary tree, so it should be a recursive function. Yes, we'll see some examples on this. So in the in order traversal example is, so we'll take one simple example. So A is the root node, left child is B and right child is C. It's very simple binary tree. So let's just start from what? Root. First you have to visit left subtree. You have to visit left subtree. So in this left subtree, we'll come to visiting a left subtree. The left subtree is what? Is a binary tree. It's a binary tree. So I should visit the node B. We have to start from node B because it is a binary tree. So you have to follow again in order traversal. So start from node B. So for this node B, as for in order traversal, first supposed to visit the left subtree. There is no left subtree. So finally, what we do? Second one, visit the node B. Nothing but display the content of node B. So after displaying a content of node B, so visiting a node is over. You have to visit the right subtree, but there is no right subtree because B is a leaf node. So once the visiting a left subtree is over for this node A, you have to visit node A. So nothing but display the content of node A. So we are done with visiting a node A after visiting a left subtree. Now we have to visit right subtree as for in order traversal. Right subtree is a binary tree. Again, you have to follow in order traversal. First start with the root. So first check with the left subtree. Is it a left subtree is there? No left subtree. If no left subtree is there, then you have to visit node C. Nothing but display the content of node C. Then you have to visit right subtree, but there is no right subtree. Right? This is the rotation. This is the sequence for this binary tree using pre-order traversal. Yes. So I hope you're clear. So we'll take one more example. So this is an example we've taken. So as for in order traversal, begin with the root node. Begin with the root node. So for this root node, first we should start with the left subtree as for in order traversal. So the left subtree is a binary tree because it's a recursion you have to follow here. It is a binary tree. Again, you have to start from node B. For this node B, you have to visit first left subtree. Left subtree is again a binary tree. Again, you have to start from root node, that is a D. Again, we should visit first left subtree. Left subtree is again a binary tree. Follow in order traversal, that is a node G. So for this node G, it's a root node. Okay, itself is a leaf node. So as for in order traversal, you have to visit, supposed to visit left subtree, but there is no left subtree for this G node. As for in order traversal, and you have to visit node G. Nothing but display the content of node G. Then for this node D, left subtree is over. I have to visit node D as for in order traversal. Nothing but display the content of node D. After displaying a content of node D, so visiting a left subtree is over. After visiting left subtree, we visit a node D as for in order traversal. So after visiting a node D, you have to visit right subtree of node D. The right subtree is again a binary tree, so we should follow again in order traversal. So again start with a node H, visit the left subtree. Is there any left subtree? No left subtree. Visit a node H. Nothing but display the content of node H. After display, okay, visiting a node H, you have to visit, supposed to visit right subtree. No right subtree for this. So for this node B, the complete left subtree is over. We followed recursion. So again visit the node B as for in order traversal. Display the content of node B. Yes, after visiting a node B, you have to visit right subtree. Yes, as for the right subtree, that is a in order traversal. So again, start from node E. Is it left child of this left subtree of this node E? No left subtree for this node E. Now finally visit node E That is display the content of node E. So after visiting a node E, I have to visit right subtree for this. The right subtree is again it is a binary follow in order. So start from node I, visit the left subtree, no left subtree. Now visit the node I, display the content of node I. Now after that, supposed to visit right subtree, but there is no right subtree for this. Now for this node A, entire left subtree is over. We follow recursion, so you have to visit node A. Nothing but display the content of node A. After visiting a node A, I have to visit right subtree of this node A. In this right subtree, again start from node C, visit left subtree of this node C. Left subtree is again a binary tree, follow again in order traversal. So first start with node F. So because this will be a root node of this left subtree. So supposed to visit left subtree, but there is no left subtree. You have to visit node F. After visiting a node F, you have to visit right subtree for this node F. Right. In this right subtree is again a binary tree, but it is a leaf node. Directly you can display the J. So for this node C, left subtree is over. We have to visit node C. Nothing but display the content of node C. And after visiting a node C, I have to supposed to visit right subtree for this, but there is no right subtree. So that's it. So this is the sequence for this binary tree. Yes, we'll see one more example. Yes, first is what G D H B E I A F J C. Have to follow how we done in the previous case. Yes, we'll take one more example for this. Yes, this is the expression discussed already in the pre-order traversal. Again, start with the root node for the in-order traversal. Visit the left subtree. Again, left subtree is a recursion. It is a binary tree. So again, follow in-order traversal. Start with the uh, multiplication node. Again, visit the left subtree. Again, the left subtree is again a binary tree. Follow in order. Start with the node plus. Visit the left subtree. In this left subtree, I have only one node. It is leaf node. Now is follow in order. So okay, supposed to visit the left subtree for this. No left subtree. Now visit a node A. Display the content of node A. Right. Next, display the content of node A. Next plus. Next B like this. It goes star. Next C. Next minus. Next D. Division. E plus. Yeah. This is the in order expression. So I hope you're clear. Yes, we'll write the code for this. So how this in order traversal steps and all, how it works, So let us take the write the code for this function for this. So I'll take one template class T because the node can store any data type. Yes, I'll take the function name as in order. The return type is what y, and we are passing the root address because we have to start from what root node. So is of type again binary tree node is of type T. So we are checking is a binary tree is empty or not. If it is not empty, I can traverse. If it is empty, I cannot traverse. That's what we are checking. If root is not equal to null, yes, if root is not equal to null, what we should follow? We have to visit left subtree. Visiting a left subtree is what? Is a recursion by passing left child address. By passing left child address. That's what we're calling first recursion. So after visiting a left subtree, there is a recursion. You have to visit the node. Visit the node means what? Display the content of node. That is what C of root of element. After displaying visiting a node, nothing but displaying a content of the node, you have to visit right subtree. The visiting a right subtree is what? Is again a recursion by passing right child address. We're calling the same function, the recursive function. This is how the code is. We'll see in the next slide in detail. So let us take the same example what we discussed for pre-error traversal. So this is the normal tree. Yes, so we have to write the sequence for in order sequence for this tree. Start with the node 2. Yes, visit the left subtree. Left subtree. Again, the left subtree. The first node is what? Root node is what? 4. Again, in this row, okay, left subtree. Okay, left subtree is a binary tree. You have to visit the node 4. I mean, start with the node 4. That is a root. So again, visit left subtree. That is a node 8. So for this node 8 is again you have to follow inner traversal. Visit the left child. There is no left child here. No left subtree here. Finally, you have to visit node 8. After visiting a node 8, I have to visit the right subtree for this, but there is no right subtree because 8 is a leaf node. So after visiting a left subtree of node 4, you have to visit node 4, that is display the content of node 4. Then after displaying the content of node 4, you have to visit right subtree, that is start with the right subtree. In this right subtree, I have only one node, that is a leaf node, that is 9. So as per inner traversal, you have to visit left, then you have to visit 9. There is no left, then visit the 9. Then supposed to visit 9 right for this, but there is no right. Yes. Now for this node 2, the left subtree is over, and finally you have to visit node 2, that is display the content of node 2. Then visit right subtree for this. Right subtree, this is the right subtree, is again a binary tree. You have to follow inner traversal. Start with the root. Root for this right subtree is what? Node number 5. Then node number 5, you have to visit again left subtree, and visit the for this left subtree is again a binary tree. So follow in order. Supposed to visit left subtree, no left subtree for this. Visit the node. Then supposed to visit right subtree, no right subtree because 10 is a leaf node. Then after visiting a node 10, you have to visit node 5. Then after visiting a node 5, you are supposed to visit right subtree for this, but there is no right subtree for this. So this is a sequence. So how to represent this using double linked list? Yes, this is a notation. This is a representation of linked list, representation of this binary tree. Yes, is the root is what? Okay, pointing to root node with addresses 111 is okay. We're checking it. If root is equal to null, no, it's not equal to null. Yes, root is not equal to null. If so, what we do? You have to visit left subtree. That's what, by passing left child address. What is the left child address for this node number 2? That is 222. That's what the root becomes what? 222. This is the root for what? Left subtree. So is the root is not equal to null? Yes, root is not equal to null. What we do? So we call the recursion. First recursion by passing left child address of node 4. What is the left child address of node 4? That is node 8. Again, the root comes to what? This left child, that is node 8. Yes, root is not equal to null. Yes, root is not equal to null. So what we do? By passing root of left child. What is the left child address? Null. Now first recursion is over. It comes to second statement. What is the second statement? CO. Okay, CO root of element. What is the root of element? That is 8. Display. Now we are supposed to visit right subtree for this, but by calling the second recursion, but it is null. It won't. Okay, it will terminate. It will resemble back this for node 4 execution. For this node 4, left subtree is over. Now root comes to what? Address 222. That is the node number 4. Now we have to visit. So left subtree is over. Visiting a left subtree is over. Now we have to visit node 4. That is the second statement. Root of element is, that is what? 4. Now we have to call the second recursion is what? By passing right child address, that is 555. What is the right child here? Node number 9. Yes, root becomes what? 555. The root is pointing to what? Node number 9. So it is root is not equal to null. Again, it calls the first statement is what? Recursion. First recursion by passing left child address. What is the left child address here? Null. So first statement is, first recursion is over. Next come to what? This visiting a node. Nothing but display CO root of element. What is the root of element? That is 9. Next is go for right subtree. By passing right child address is what? Null. So it will terminate the second recursion. Now it resumes back this root node, that is 2. The left, okay, first recursion is over for this. Now it will visit the node, that is by displaying root of element. Nothing but content of root node. Now here, okay, we are calling second recursion. Second recursion is what? By passing right child address. What is the right child address? That is 333. Root becomes what? 333. So is root is not equal to null? Yes, root is not equal to null. What we do? We call the first recursion, that is by passing left child address. What is the left child address? 666. Now root becomes what? 666. The root is not equal to null. Yes, root is not equal to null. What we do? We call the first recursion again by passing left child address. What is the left child address? Null. Now root becomes null. The first recursion over. Now what is the second statement? Root of element. What is the root of element? That is 10. Now come to second recursion, that is by passing right child address. What is the right child address here? Null. Now again left subtree is over. Visiting a left subtree is over. That is the first recursion is over. It comes to what? Second statement recursion. That is second statement is what? Displaying a content. Ultimate visiting a root node. That is what? CO Root of element. What is the root of element? Where is the root? There is no 5. Root of element is what? 5. So what is the right, then you are supposed to call second recursion by passing a right child address. What is the right child address? Null. It terminates. So I hope you are clear with the in order traversal. Thanks for watching.